Did you know our sun is dying? Yes, you heard that right. The very star that gives us light and life is slowly but surely heading towards its inevitable demise. It's a natural part of the cosmic life cycle, a destiny written in the stars. Now, before you start panicking, let's put things into perspective. This event won't occur for about 5 billion years, that's right, billion with a B. The sun, like other stars, undergoes a life cycle dictated by the fuel it burns. In our sun's case, that fuel is hydrogen. When the sun exhausts its hydrogen reserves, that's when we'll start to see some serious cosmic changes. But again, we're talking billions of years in the future. So, there's really no need to start getting your interstellar travel plans in order just yet. But don't worry, we have plenty of time before we need to start packing our bags. So why is the sun dying? And what does this process look like? Let's delve into the fascinating world of stellar life cycles. Our sun, like all stars, is a giant fusion reactor. For billions of years, it has been converting hydrogen into helium, releasing a tremendous amount of energy in the process. Let's dive a bit deeper into this process. Picture, if you will, the heart of our sun, a fiery, churning cauldron of unimaginable heat and pressure. Here, in this stellar crucible, an intricate dance of subatomic particles plays out. Hydrogen atoms, under the extreme conditions, collide and combine to form helium in a process known as nuclear fusion. This fusion releases a vast amount of energy which powers the sun and provides light and heat to our solar system. But there's a catch: the sun's hydrogen supply isn't infinite. It's gradually being depleted with each moment of fusion. You see, the sun is like a car running on a finite tank of fuel, only in this case the drive has been going on for about 5 billion years. And just like a car, once the sun's fuel starts running low, things begin to change. As the sun continues to burn through its hydrogen, the core shrinks and heats up. This increased heat pushes the outer layers of the sun further out, causing the sun to expand. But we'll delve into that in the next scene. The sun's hydrogen depletion phase is a slow countdown, a cosmic hourglass marking the passage of eons. It's a natural part of the life cycle of stars, a testament to the finite nature of existence, even for something as seemingly eternal as the sun. And when the hydrogen fuel runs out, that's when things start to get interesting. Or rather, intense and expansive. Imagine our sun expanding, growing larger and redder. This is what we call the red giant phase. In the heart of our sun, a monumental change is taking place. The hydrogen fuel that has kept our sun shining for billions of years is running out. But the sun is not ready to bow out of the cosmic ballet just yet. As the hydrogen depletes, the sun starts to burn helium instead. This shift in fuel marks the beginning of the red giant phase. The red giant phase is a rather dramatic one. As the helium in the sun's core burns, it causes the sun to expand. And when we say expand, we're not talking about a slight increase in size. We're talking about an expansion so extensive that the sun could potentially engulf the inner planets of our solar system, including our very own Earth. Now, this might sound like the plot of a science fiction movie, but it's actually a natural part of a star's life cycle. As the sun swells into a red giant, its outer layers will extend outwards, growing hundreds of times its current size. This expansion could reach as far as Earth's current orbit and possibly even further. What would this mean for our planet, you ask? Well, if the Earth isn't consumed by the sun's growth, it will at the very least be subjected to intense heat and radiation. This could result in the evaporation of our oceans, and potentially the end of life as we know it. But it's not just Earth that would be affected. The other planets in our solar system would also feel the effects of the sun's expansion. The outer planets might find themselves in warmer climes, while the inner planets could be engulfed entirely. So our sun, the very source of life, could potentially become the harbinger of destruction in its red giant phase. But remember, every ending is a new beginning in the cosmos. A red giant, a dying star, but what comes next is the final act of this cosmic drama. After the red giant phase, our sun will shrink and become a white dwarf. A dramatic change, isn't it? From a fiery, burning inferno, the sun will transform into a cooler, denser version of itself. It's like a cosmic retirement, if you will. But don't be fooled, this white dwarf is anything but dull. White dwarfs are compact stars, roughly the size of our Earth, but with a mass close to that of the sun. Imagine cramming the sun into a space the size of our planet. That's one dense star. But that's not all. The surface temperature of a white dwarf can exceed 50,000 degrees Celsius. That's hotter than the sun's surface temperature now. But what happens next is truly fascinating. After the sun has shed its outer layers during the red giant phase, what's left is a core rich in carbon and oxygen. This core, the white dwarf, is surrounded by a thin layer of hydrogen and helium. Over time, the white dwarf cools and dims. This process can take billions of years, turning the white dwarf into a black dwarf, a cosmic ember fading into the darkness of space. But here's the silver lining. The sun's death will enrich the interstellar medium with heavy elements. These elements, ejected during the red giant phase, will drift through space carried by stellar winds. Over time, these elements may come together, under the influence of gravity, to form new stars and perhaps even planets. It's as if the sun is giving a parting gift, passing on the baton to the next generation of stars. And so even in death, our sun contributes to the birth of new stars. A cosmic cycle of life and death, isn't it? Our sun, even in its twilight years, remains a vital part of the cosmic dance, a testament to the enduring wonder of the universe. The life and death of our sun is a story of cosmic proportions, quite literally. We've journeyed through the sun's life cycle, from its current phase to its eventual demise. Let's take a moment to recap this stellar saga. Our sun, in its prime, is a bustling hub of nuclear fusion, converting hydrogen into helium at its core. This is its main sequence, where it spends the majority of its life. But nothing lasts forever, not even the life-giving sun. As the sun exhausts its hydrogen fuel over billions of years, it will enter the hydrogen depletion phase, causing its core to contract and its outer layers to expand. This expansion heralds the onset of the red giant phase. Our sun will grow immensely, reaching out into the solar system, potentially engulfing our very own planet. It's a fiery, tumultuous phase as the sun struggles to hold on to its spent materials. The final act of this cosmic drama is the white dwarf phase. After shedding its outer layers, the sun will shrink down to a dense, white-hot core. It'll be a mere shadow of its former self, slowly cooling over the course of billions of years. Throughout this process, the sun's death will contribute to the interstellar medium, enriching it with heavy elements. This could potentially give birth to new stars, making the sun's demise part of the universe's continuous cycle. So, while the death of our sun may seem like a grim topic, it's a natural and fascinating part of the universe's ever-turning cycle of life and death. And there you have it, the life and death of our sun, a testament to the incredible phenomena that govern our universe, from its birth in a stellar nursery, through its hydrogen-burning phase, to its eventual swelling into a red giant and settling down as a white dwarf. The sun's journey is a mirror to the cycles of life and death that happen all across the cosmos. It's a poignant reminder of how, even in the vastness of space, everything is interconnected. Now, remember to hit the like button if you found this video informative, subscribe for more content like this, and tell us what you think of all this in the comments below. Until next time, stay curious and keep exploring the cosmos.